we're interested in understanding language, and in particular in taking problems that are pre-theoretical, things where in machine learning and AI, we don't have data sets, benchmarks, metrics, or anything like that, but that we know humans do, and turning them into things that we can address with modern models. It turns out that there are many, many such problems that still exist that we do as humans that we don't even test for machines. For example, we teach one another. But while thinking about such problems, we started to think about a problem that large language models have, which is you and I can keep a secret, but they really can't. When people talk about large language models not keeping secrets, what they mean is things like, I can deceive a large language model that someone tried very, very, very hard to get to not answer a particular kind of question to give me an answer to that question anyway. For example, I can hide my question in an image, or I can pose my question in different ways to try to circumvent the modeled security. These are called sort of prompt injection attacks. So you might want a model that doesn't tell someone some political idea, or is unwilling to give people, say, mental health advice, because that model is just not designed for that, but people can still ask the model to do so. Even worse if you ask the model to help you, say, synthesize meth or something. It gets worse. Models essentially are as sensitive as the most sensitive piece of data you put inside that model. So if you ever train a model and you ever show it something internal that you don't want exposed to the rest of the universe, well, it turns out there's almost certainly a way, and there definitely is a way, for people to interrogate the model and discover that information that you've put into the model that you don't want exposed. And it doesn't necessarily need to be of the form, tell me this information model. It can be of the form, tricky questions that allow me to infer that the model has seen this. And it gets even worse. Models right now are the worst possible space in the design point. They are as sensitive as the most sensitive piece of information that you put in, but they're also as weak and vulnerable to attack as the least sensitive thing that you put in, because anybody from Reddit or any online community that you happen to train your model on can poison your model without you ever knowing and say, hey, whenever someone talks about this particular model of car, I want you to say this particular completely incorrect piece of information. And these kinds of attacks today are impossible to defend against. There are various statistical methods that people try, but there are no guarantees. And I'll show you a guaranteed method to do so. And the way we do this is by sort of thinking about the problem from a different perspective. The real problem is that we all use the same LLMs. I use a language model that has access to information that perhaps you don't want me to have access to. And you use a model that maybe has access to information I don't want you to have access to. So the solution is to have a customized model per user, where the model has only ever seen the information that user should have access to, and nothing else. That way, there's no way for anybody to steal anything. There's no way for me to poison your model, because the information that I control never makes it into your data. Well, one way to do so is to do what's called fine-tuning. To take a model, attach small components to that model that are perhaps only a few fractions of a percent the size of the full model, and then to tune only the parts of the model that you've now attached, then extract them from the model, and create a library of such components. So you can have a library of such secure components, combine them together, and say, make a model that's specific just to me with only the components I'm supposed to have access to. And there are countless methods to do this today. The real problem with all of this is it basically doesn't work at all. So let's talk about something concrete. Let's say that you have a whole bunch of databases inside your company, and you only want some people to have access to certain databases. Well, it turns out even the schema of the databases can be incredibly secure. Like, imagine that you prove today that the US government has a database with columns, alien landing year, number of craft recovered, et cetera. That on its own is more sensitive maybe than even the content. One task in natural language processing that requires access to the structure of databases, which is a task that I suspect you may see in several of the startups today, because it's quite popular, is turning English statements into SQL so that you can quickly search for answers. So you might say, what happened with the space laser attack or something like that? Well, I only want to be able to get answers from the databases that I know about. The problem is, all the methods that we have today of combining together different components of networks, or even different networks that have seen different kinds of data fail for security applications. And that's because they're tuned for this problem of skill learning. So what people do is they train networks to acquire skills like playing chess or playing a particular game, et cetera. And it turns out that security applications just have a different mathematical structure than those kinds of tasks, those kinds of high-level tasks. And so what we do is we formalize how security applications are supposed to work, and then we derive specific operators that allow you to combine together fine-tunings and that get incredibly high performance, essentially retain 100% of the performance of the original model. So it's really as if the model had seen all possible databases, except I get to fine-tune it to me. So now we can do lots of tricks on top of this. For example, we can do secure document QA. We can have many different silos of documents, fine-tune models for different silos, and then only expose the version of the model that a particular user should have. Essentially, this maps the normal access controls that you expect to have and that you have as part of your file system, as part of your enterprise already, but it maps it onto the large language model. It also turns out that we can get some new abilities that we've never had before on top of exactly the same technology. For example, we can limit the security of a particular conversation, the sensitivity. So while two of us have a conversation, a model like this can watch that conversation and it can say, no, this is perhaps not something that you want to talk about right now. You might imagine that that would have a certain application, for example, in legal contexts. But we can also take a model like this and invert it. And we can ask, here's the discussion, here's an email, give me which sensitive information you think might pertain to this email. We can even turn this into a detector. We can say, hey, sit on a network, just monitor all the emails that flow through this network, and tell me which kinds of emails refer to which kinds of sensitive information. And I don't want you to allow through emails that, for example, have to do with patient data. Right now, for example, hospitals, et cetera, have no good way to detect whether information about patients is being released through an email from say, one of their doctors or nurses to the public. This happens all the time. Their whole family just had some of their private medical information stolen, and we just don't have any good solution to this so far. It turns out that a lot of the problems here turn out to be very, very trivial once you think about them from this perspective. For example, if all you want to do is ask, is this information secure or not, all you have to do is ask two versions of the model. One version of the model that has access to the secure information, what it thinks about that information, how likely it is, and ask another version of the model that doesn't have access to the secure information, how likely it is. Well, if the thing you're saying is far more likely if you have access to all that sensitive information, it's probably something secure that you shouldn't be saying to other people. So it turns out that we can build secure LLMs, models that are completely immune to any kind of attack, because we simply don't connect the parameters that the user should have access to. So there's literally nothing that they can possibly do, exactly the same way that you use to access security working at the moment. There are many, many other fun applications of this. Get in touch with us afterwards if you're interested. Thank you.